Okay, let's look at a new unit, kind of looking at the area. Some of this may be review. Again, some may be expanded on prior knowledge. So let's kind of take a look at this. If we look at a parallelogram, our area formula is really the same as it were to be a rectangle. And again, the reason why that is or why that works is if I were to cut this out and move it over here, if we were to outline it, end up with a rectangle. So where we find the base and where we find the height may change, but essentially our area formula is base times height. A triangle, again, is very similar to the area formula of a parallelogram. It is base times height, but divided by 2. So again, if I were to look at a rectangle, base times the height, I have one triangle here and one triangle here. So base times height divided by 2 gives me my area. So if we take a look at the example, again, what's my base? My base is 30. My height is 17. So again, make sure you have a calculator handy. 30 times 17 equals 510 units squared. Area of a triangle. Now, this is important. The base is where your height intersects at a 90-degree angle. So again, I know all 3 sides of this triangle, but because this one altitude, this one height is creating a right angle with 21, I'm going to use that. So I'm going to say the area equals base times height divided by 2, 8 times 21 divided by 2, which is really 4 times 21, which gives me 84 units squared. Find the perimeter. So again, perimeter is another word for like the outside. If you think about a fence goes around the perimeter of a property. Since this is a parallelogram, I can state that this side is congruent to this side, so this is 6, and then this side right here is congruent to this side, which is 12. So my perimeter of parallelogram QRSP is equal to 12 plus 12 plus 6 plus 6, 24 plus 12, 36. And again, I'm not sure what my label is. But area is going to be the area of a parallelogram. So right here, I see that, okay, I do actually have a base of 12 and a height of 4. So the area of my parallelogram equals 12 times 4. 12, 24, 36, 48 units squared. Our area is always squared, our units. All right, if I look over here, find the perimeter and the area. So perimeter, I'm going to have to use the Pythagorean theorem. This is my hypotenuse. This is a leg. This is a leg. So leg squared plus leg squared. I'm going to call this just x plus x squared equals 13 squared. 25 plus x squared equals 169 minus 25. X squared equals 144. And so the square root of 144 is 12. So my perimeter is pretty easy to come up with. My perimeter of my triangle is 5 plus 12 plus 13, which is 30 units. Area of a triangle, (5 times 12 divided by 2, 5 times 6 gives me 30 units squared. The base of a triangle is twice its height. The area of the triangle is 36 square inches. Find the base and the height. So we kind of have a picture. Again, that's helpful because I can say h times 2h equals 36. But I have to remember that my formula for a triangle is divided by 2. So again, if I'm just trying to simplify, I get h squared equals 36, which means h equals 6. So my base, again, 2 times 6 is 12, and my height is just 6. So to answer the actual question, again, base equals 12, height equals 6. We also have a few different types of shapes as well. We have a trapezoid, a rhombus, and a kite. Trapezoids, remember, have 2 parallel lines. And so if we look at how this area formula is calculated, it's almost like we have one triangle right here. And we have, if it's an isosceles trapezoid, the same triangle over here. So that's, again, we kind of have 1/2, and then you see times height. It's very similar to the formula of a triangle. But what we're doing, we're also taking the average of the bases. So yes, we're multiplying by the height, but we're going to add up the bases and divide by 2 to get the average. A rhombus uses the diagonals. So again, in order to calculate a rhombus, you need to know what this line is right here, again, from one vertex to the other, and you need to know what this line is here. So again, if this was called D2, this one could be called D1. It doesn't really matter as long as they are the same, like as long as you're consistent, because the order of multiplication doesn't matter here. And the kite formula is exactly the same. Just know that kites have different properties. Again, kites have 2 sets of congruent sides, so it's a little different, whereas rhombuses have all 4 sides. All right, let's take a look. This is a trapezoid, a funky looking trapezoid. So I'm going to use my formula. Again, I'm going to multiply by the height, which is 4. I'm going to find the average of the base. Excuse me. So again, if I try to simplify, 6 plus 8 is 14 divided by 2. 4 times 7, 28 feet squared. I have one diagonal right here, which is 14. Another diagonal of my kite, which is 6. So my area is going to be 6 times 14 divided by 2, which is the same as 3 times 14. So 3 times, let's call that 42 inches squared. Now I don't necessarily have the whole triangle here, but I can fill in what I know. I have 30 here. I have 40 here. And because it's a rhombus, I know that these bisect each other. So that means that this is also going to be 30 and this is also going to be 40. So really I have an 80 times 30 and again divided by 2, which is going to give me, let's see here, 40 times 30, 1,200 meters squared. What you may end up having to do when you're doing your practice is, again, if you get something like this, if this was 5 and this was 4, and you were looking for right here, you may have to use the Pythagorean theorem. So call this h. H squared plus 4 squared equals 5 squared. H squared plus 16 equals 25. H squared equals 9, therefore H equals 3. You may, and again, that could occur right here. So we have to, again, use things that we've done throughout the year to figure out what we need for the equations. You have a map of a city park. Each grid represents a 10 meter by 10 meter square. Find the area of the park. So again, I'm going to annotate this up. See here, 1, 2, 3, 4. My height is 5 and my base is 1, 2, 3. Oh, I can't, that's not correct. I got to count the whole thing. 1, 2, 3, 4, 5, 6, 7. Now, because it's a trapezoid, I need to know the top base as well. 1, 2, 3, 4. So my formula for a trapezoid is to take the height and find the average of the bases. So I'm going to say that this is equal to 5 times 11 over 2. Let's see here. 55 over 2 is 27.5 meters squared. If you were to go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you have all these partial pieces. So I could take part of this triangle into part of this triangle, that counts as 1. Part of this triangle into part of this triangle, that counts as 2. And you would eventually get 27.5.